Okay, let's get started here. We're going to talk about the exploratory data process. And before we get started with that, we're going to talk about what it means and what to get started, blah, 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 blah. So before we start a data set, we want to explore it. Exploratory data sets or exploratory data process or just anything we can do to figure out what the thing looks like before we get started. If you type this into the internet, you're going to get a whole bunch of different lists on what to do. But at the end of the day, what you're really trying to do is understand what it looks like so that we can decide whether or not we can move forward with our additional, more sophisticated decision-making process, and etc. The first thing I like to do is find missing data. Okay? Let's find missing data. Well, you know, I'll give you my short list. Number 2, I like to do descriptive statistics, right? Stats, plural. Number 3, I start looking for, I do plots and graphs, trying to identify things like outliers and a bunch of other stuff. 4, I'll just put outliers right here, outliers. 5, and then you look for everything else. Everything else. And, you know, this is super weird. It's like a grab bag. This is relatively new. From an academic perspective, this stuff's relatively new, so it's hard to know what it is that we're teaching you other than the list of stuff. Like, algebra's been around for 1,000 years or more. And so that's easy to teach, right? This stuff we're still trying to figure it out. So KC House data is a data set that I like to do. I'll put a link in the video. You should have it in your tabs. As always, we start with making it pretty. A pretty data set is a strong data set. I like to clean it up a little bit. We're going to turn around and put these lines down here, which I like. I like to bold out the tops of this stuff. We can also turn around and just make it a little easier to read by spreading out the data. That's too far. I don't like that one. But some of these I can't read, so I'm going to spread them out a little bit better. That's fine. This data set has about 500 observations. That's a control down arrow. Control up arrow brings you to the top. You know, the other thing we can do real quick is go to view. And under view, I want to freeze that top row so that I know what I'm looking at when I'm looking down there, right? This data set is also sorted already by price, which I don't like. I want it to be super random when I first look at it. We'll do some sorting down the road a little bit. But number 1, let's look for missing data. This data set reflects all of the purchases that occurred in 2014 and 15 in Kings County. That's Washington, that's Seattle. And so some of these house prices for, you know, when this came out in 2014, 2015, was a little high compared to the rest of the country. Maybe not so high anymore following what's happened in the last 2 years here. But we're going to look primarily at this one variable. Remember that my columns are my variables, right? So I had, it's a variable, singular, right? Variable 1. And that each column represents one variable, right? So we're going to do this one variable at a time where the rows then represent one observation. And in this data set, one observation represents one sale of the one house, okay? So let's delete that and get it out of the way. Try to keep this clean. So the very first thing is I'm going to look for missing data. I don't see a lot of missing data here. It looks fine. One way you can do this is control down arrow. It takes me all the way down to the bottom. I don't have any missing data. But if I did have missing data, I'd have some decisions to make. With missing data, let me give myself some space to write here. With missing data, we've got to figure out how to do with the entire observation. So my first option is to delete the entire observation. This is the lazy man's approach, but it doesn't mean that it's wrong. Deleting an observation could be perfectly valid, especially if you have 500 observations. Is it really going to be an issue? That's up to you. In considering whether or not to delete, I would look at the number of observations. If you have a bunch of observations, it's easier to delete the one. It shouldn't affect it. I would look for subgroups, maybe sensitive subgroups or underrepresented groups, right? If we were looking at, if you lived in South Texas, where we are, and there's a large Hispanic population, and the one who's missing information happens to be a native Hawaiian Islander, then by deleting that one observation, I may lose it I may lose that representation altogether. So we're really talking about representation here. And if it's not a big deal, then I might just remove it altogether. Number two, I could fill it by estimating. And there's a variety of ways to estimate. You can estimate by taking the average of all the other stuff, right? And if I were to take the average of all the other stuff, and let me do a very short version here, equals average, and just grab a bunch of these real quick, just to see what that looks like. I get 554,000, right? That guy. Is that an appropriate representation? Well, maybe. But maybe more importantly, I see that this is a 4-bedroom house and that this average includes 3 bedrooms, 2 bedrooms, 3 bedrooms, 2 bedrooms, 3, 3, 3, 3. That might not be representative. I might want to do something a little bit more sophisticated by taking the average of all the 4-bedroom houses. That might get me closer, right? What was the original? I don't know what the original number was. And that's fine. I'm not going to worry about it. So now we've taken care of our missing data. Check. So we're good to go. Let's do descriptive statistics. These are relatively simple. They're very classic. Again, we're just dealing with the one variable right now, not getting carried away. And we like to do these at the bottom, right? Average. I don't like the word average. I like the word mean, median, mode, min, max, standard deviation, right? Those are the basic ones. And here's a little bit of a cheat for those of you who haven't done this before. The easy one is the average. So I'm going to type out average, tab, and then I'm going to go up and highlight the entire box. Control, Shift, up arrow takes me all the way to price, but I don't want the top one. So I let go of everything and I hit Shift, down arrow, one row, and it selects the entire row. I hit enter, boom, I have the mean, right? But I know I want to copy paste this, so I'm going to F4 the cells and F4 the cells again. And now that's all locked up and nice. And I'm going to copy paste down. Here's the trick. Obviously, I'm pasting the average down to everything else, but what I'm really doing is carrying the range that I'm going to use. Then I can switch average to median, and it calculates the median. And I can switch mode to, or average to mode, and it calculates the mode. And it kicks, min to min, max to max. And when in doubt, I would suggest that your standard deviation is the one with the S for sample. Certainly, if you were in my class, I would suggest doing the sample every time. There's a slight difference between the sample and the population. Just use the sample. Most of the time, you'll be okay or close, right? And now I have all my descriptive statistics. What is it about the descriptive statistics that I care about? I care, first and foremost, about these three, which we would call the variables, the statistics of central tendency. This is important. So, why do we care about central tendency? Let's see if I can make some more space up here. Nope. Don't always show the, go away ribbon. Well, maybe I can't. If we want to believe, or we want to know that this is a normal distribution, a normal distribution might look something like this. And what's in the middle of a normal distribution? My mu, right? Otherwise it's known as the mean. Let me go down exactly one, right? The mean, right? So now I've got the mean and it's right in the middle. If this is a perfect normal distribution, I also know that 50% of the population is in the left tail and 50% of the population is in the right tail. If that's true, what else is in the middle? Well, the median, For those of you who don't know, another word for the median is the 50th percentile, right? Now, when we do a normal distribution and we have this left wall up here, this on the left-hand side is measured as the frequency, or the number of observations. So what is the mode? The mode is that number that has the largest amount of observations. Largest. And where is it? It looks like it's in the middle as well. So the easiest, quickest, fastest way to know or to believe that you have a normal distribution is to see if the mean, the median, and the mode are all right up next to each other, right? And in this case, they are not, right? So I have 525, I have 437,000, 315,000. That's a bit of a problem. It's not normal. It might be normal-ish, but let's take a look at that, right? So and then I look at stuff like the min, way down low, the max, way up high. Like there's stuff all over the place here. In terms of our stuff, we have checked the descriptive statistics box. We're good to go. Graphs and plots are next. The two that I want to do here are going to be the histogram and a scatter plot. Although the scatter plot is a bit of a cheat. Maybe I won't talk about that. We'll see. Excel is great because I can do the same thing. Control Shift up arrow. And if I go up to insert, I have right here in the middle the statistics charts. The very first one that I want is my histogram. And that does not look like a normal distribution. Can I make it bigger? Let me see if I can make it bigger. Whoops. No. Go back. Thank you. That does not look like a normal distribution to me. Get bigger. Did it again. See, it's not just you guys that mess it up. I mess it up all the time too. There we go. There's our normal distribution. I have so many bins. Oh, it's not truly normal. Let me change colors to something else. This distribution looks like it has a long right tail. And if my median is somewhere in here, it's not. It's in here somewhere. Where is my mean going to be? Well, I can know by looking at the chart that the mean is bigger than the other one, so my mean is going to be over here somewhere, right? It is not normal, but it looks kind of close. I would go ahead and move forward with something like a linear regression. You can probably get away with it, although it's not perfectly normal. I'm already thinking, by the way, that there are some outliers out here. Outliers, maybe. There might be some outliers out here. Okay, so that's good and that's fun. The next thing I want to do, oh man, I shouldn't have done that. Control Shift up arrow. Let's make some space over here, and let's insert back to the statistical charts our box and whisker plot. Now, the way to read this is actually very important. Hopefully I'm not going too fast. The way to read this is actually pretty important. A box and whisker chart is broken up into 25 percentiles. So this guy right here is the bottom 25th percentile. You can barely see this line here in the middle of the box. And between this line and this line is another 25% of my observations. Between this line and this line, I'm just spreading it out so you can read it, 25% of the populations. And finally, between this line and this line is 25% of my population. That gives me this block of observations that are so big that they don't really even fit inside my total population. These are outliers, right? I would probably cut the outliers number about here. There seems to be a gap in there. If you wanted to cut it down here, that would be perfectly acceptable. Usually when we look at outliers and we have a plot like this, we cut out the bottom 1%, that gets cut out, and the top 99% often will get cut out. But if you're going to continue with this particular data set, you can identify these outliers. And how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. More importantly, I can kind of walk over and I can say somewhere at about 1.2 million is probably my cutoff. And now because I have structured my data, I can sort it largest to smallest. And here is my 1.2 million, más o menos, more or less. Probably in here somewhere. I would probably throw these out. Or the 2 million mark, right? I might go to the 2 million mark. There's a very big jump here between 2 million, 1.5. And I would call these my outliers. I would delete these guys from my observation, right? And so that's the short version. We've done plots and graphs. We've done outliers. Everything else. At this point, man, what we're really looking for is what does it look like? What does it look like? What is interesting? Are there any hypotheses in here that I can dig out? To this end, let me erase this real quick. To this end, the table format in Excel works very nicely. Because if I were to say sort by bedrooms and say, hey, look, I only want to look at the 3-bedroom deals, then I'm looking at all the 3 bedrooms, right? And I can do all the same similar calculations that we do from here. So Control-Shift down, I highlight them all. And one thing I want to point you to, I don't know if it's on my screen, I don't think it is, but if you look here on your screen, you will see the average, the sum, and the count automatically calculated for you for those that are highlighted by your mouse. And this is the kind of thing that might help you work through or walk through trying to make some decisions about hypotheses, right? So if you're doing exploratory stuff, and we want to do this every time you get a new data set and start playing with it, and that's the other thing, right? Just play with the data. The data is messy. Data is almost always super messy. And what you're trying to do is make it make sense to you so you can do something with it and come and decide whether or not your hypotheses are worth exploring, that you're not missing data, that you can explore them, that the variables you're using are categorical or not categorical, that they're qualitative, not quantitative, or the other way around. I guess in our case, we want them the other way around. Data's messy. You got to know what it looks like before you move forward. At the end of the day, you would hate to do all of this work, present it to someone, a client, the research academy, whatever, your professor, and then your professor says, wow, that looks really great, but the distribution's not normal. And you turn around and say, well, what does that mean? And it means that everything you've done is invalid, right? Because you have not met the basic assumptions of the next step, which is the more sophisticated statistical analyses. All right. Have fun exploring data sets. Look at those statistics, graph them out, identify the outliers, and enjoy the process.